So this meeting will be recorded. So welcome everyone. Thank you for joining the Columbia River Turning Basin Improvements Feasibility Study and Environmental Assessment Public Information Session. My name is Karina Holfus. I work with Tetra Tech and we have been assisting the U.S. Army Corps of Engineers with the environmental documentation for this project. And like I just said, this meeting is recorded, so you are being recorded if you provide a comment. And the recording will be provided on the website after the meeting. So here's an agenda for this evening. So I'll provide a quick 5-minute overview with how to use Zoom and just the plan for this evening's presentation. Then I will hand it over to Elliot, who will provide a 40-minute presentation about the project overview. And then we will open it up for questions. So if you have any questions, please save them for the end. The meeting is scheduled until 7:30, so at 7:25 I will provide closing remarks and wrap up the meeting. So asking questions. If you have a formal comment, please submit the comment in one of 3 ways. You can either send it to this email address listed here, you can provide your comment on the website listed here, or you can provide your comment via mail and mail it to this address. Also, no need to rush and write this down. These addresses will be provided several times throughout the presentation, and they'll be left up on the screen at the end of the call. So if you have a question, please enter your question in the chat and start with your name. You might notice that you are muted right now, so if you have a question, please use the chat. All chats will go to the meeting administrators, and the moderator, myself, will read off the questions from the chat at the end of the presentation. If multiple people ask the same question, we'll just summarize so we do not repeat several questions. So tonight we're only answering questions regarding the project description, the NEPA process, or the comment submittal process. If you have a formal comment, please provide it in one of those 3 ways listed before. Opinions and commentary will not be read aloud during this meeting. And as I mentioned, a recording will also be provided on the website after the meeting. And we ask that you please be respectful of our speakers and of each other. So some quick Zoom webinar tips. If you haven't used Zoom webinar before, your screen should look somewhat similar to this screen here. You'll have a taskbar at the bottom of your screen, and you will see the chat button. So if you'd like to ask a question, please click that and then type in your message and hit send. And also, please put your name in the chat as well so I can call on you. So after this meeting, this presentation as well as the recording will be made available on the website. Once again, if you would like to submit a comment, please email it, visit the website, or provide it via mail at that address. All right, and I will hand it off to Elliot to provide a project overview. Elliot?
Yeah, thanks, Karina. My name's Elliot Porter. I'm a planner with the Portland District, U.S. Army Corps of Engineers. And I'll be providing an overview of the plan formulation process, the selection of a recommended plan, and some of the key content from our draft document that's posted on the website. If we can go to the next slide. So tonight's agenda, Karina already covered some introductions for us. We'll talk a little bit about the study schedule, the background, why are we doing this study, what are we hoping to achieve, the plan formulation that we went through, the resulting recommended plan that is in the draft report. We'll have some discussion on our environmental compliance and environmental consequences, the timeline for project completion and implementation, and then we'll go back to those slides that Karina shared earlier on how to provide input formally. Next slide. So we're a little over halfway through the study period. We are, if you look at the bottom, at draft report release for concurrent review. That started on July 3rd with our press release and the posting of all of the documentation online. That begins a 30-day public comment period, which we're in the middle of right now. It's scheduled to close on August 3rd. So they do ask if you're thinking of submitting comments that you do it by that deadline. Once we complete the public comment period, We also have a technical review and a policy and legal compliance review going on at the same time. We will work to address all of the comments, incorporate them into the draft document, and then we hit our next milestone, which is listed there in October, the agency decision milestone, where the agency confirms the recommendation that we put forward as the plan that we support. From there, we work through mostly administrative processes in terms of developing the Chief of Engineers report, which is the document that goes to Congress, becomes an authorization, and provides us the authority to implement this project in the future. So the goal is to complete this project and have a signed Chief's report by September of next year, and that is right along our 3-year timeline. Next slide. So the area that we're looking at are at the ports of Kalama and Longview. It's about 2/3 of the way up to Portland and Vancouver on the Columbia River. These were areas that were considered in the previous channel deepening project, and we have been specifically asked to look at improvements or additional turning basins within this reach. Next slide. So the reason why we look at this and the reason why the Columbia Snake River system is important is that it is a vital means of commerce for the region. It moves a lot of cargo, primarily exports of farm products out of the Columbia River and into the Pacific Rim. The lower Columbia River is #1 for U.S. wheat exports, #2 in soy and corn exports, and #3 globally in grain exports. It's also the #1 West Coast port for forest and mineral bulk exports. In 1999, the Corps of Engineers was authorized to deepen the existing Columbia River Federal Navigation Channel from 40 to 43 feet. Since then, the ports have invested an additional $1 billion in infrastructure, which has led to increased utilization, the ability for larger ships and larger volumes of material to go out. And so we're taking a relook in terms of the system needs to meet not just our current but our future demand. Next slide. So the current problems that we've identified within the study area is that the existing federal turning basins are overutilized. They're insufficient. The ships, since the channel deepening, have gotten larger. They're deeper drafting. And this has resulted in congestion, increased use of tugs, and tidal delays. We also see frequent shoaling and low water at the Port of Kalama. They currently maintain an area in front of the Temco grain terminal. In the late summer, coinciding with low water, we also see shoaling in that area, which results in decreased depth. So we find ships need to wait at the Temco grain elevator after being loaded before they have sufficient water to depart. The lack of turning basins in the lower Columbia require that vessels travel upstream or downstream to turn, which increases traffic. The Port of Longview is the last port on the Columbia River before you get to Astoria. And the area between Longview and Astoria is very remote with limited services. So if there's any type of emergency situation or a requirement to turn a vessel or to anchor a vessel, they have to move upstream a pretty significant way beyond Longview and Kalama in order to do that. As I mentioned earlier, the channel deepening of the Columbia River has resulted in significant expansion, not just at the ports of Kalama and Longview, but especially at the ports of Kalama and Longview, where we don't necessarily have the capacity in the existing turning basins. We anticipate some increased severity and frequency of storms that will close the bar. During bar closures, vessels that are already within the system need to be anchored or need to find a place to wait until the bar reopens and they can leave the system. And as I mentioned earlier, the ports of Longview and Kalama are the first ports on the Columbia River. And so without sufficient navigation facilities to turn and anchor vessels, it creates a safety concern. Next slide. So the objectives for this study are looking at ways to improve the utilization of our existing facilities to maximize capacity within the system. We're looking to improve the efficiency of vessel loading, reduce tidal restrictions, and maximize our transportation cost savings by getting vessels on and off the berth more quickly. As I mentioned before, where we see insufficient depth at these turning basins, or we see shoaling during periods of low water, it results in queuing and increased transit and turning times. Overall, we're looking for opportunities to improve safety in the lower Columbia River, but especially during periods of closure at the mouth when vessels cannot come in or go out of the system. And then we're looking not just at today and what today's needs are, but over a 50-year planning timeline to understand what the future needs of the system might be. Next slide. So when we started this project, we looked at a whole range of issues, even more than what we're showing here, but these were the primary ones. What you're seeing in bold are the ones that we considered implementable and measures that would achieve our objectives. Based on the congressional authority that we got for this study, we're specifically focused on improvements or establishment of new and existing turning basins. And so any project or any recommendation that we looked at included consideration of modifications of the existing turning basin at Longview or establishment of a new turning basin at Lower Martin Bar, which is at the Port of Kalama. Additionally, we looked at adding stern anchor buoys, which are areas for vessels to anchor. We looked specifically at fully laden vessels that require the full 43-foot draft so that we have additional areas to place them outside of the channel to decrease congestion and improve safety. And then we also looked at sediment catchments, which are overdredging areas that catch sediment before they begin to impact our navigation features. And so those were the four that we carried forward. We looked at some other primarily maintenance reducing alternatives like pile dikes, perpendicular dikes, and maintenance in other areas of the river to reduce the volume of material that was impacting the turning basins. They were eliminated for various reasons, primarily because the cost associated with them was beyond the benefits that we could hope to achieve. Next slide. So we took those just handful of measures and we formed them into alternatives. We looked first at the Longview turning basin by itself, and this is improvements to an existing federal turning basin. Our second alternative was looking at establishing a new turning basin at Lower Martin Bar. We considered them individually to make sure that they were economically justified on their own, and then we combined them together and ensure that they were economically justified together. And then finally, we looked at the combined turning basin with stern anchor buoys for additional places to anchor those vessels. We did have two additional alternatives that were eliminated upon further analysis. Both of them included the sediment catchment. The idea with the sediment catchment is that you overdredge an area and you reduce the frequency and or the volume of material that needs to be dredged on an annual basis. During our analysis, we determined that it would not decrease the overall annual volumes or the frequency that we would need to dredge. So it was just additional cost without any additional benefit. Next slide. So I'm going to walk through the alternatives that we considered and just kind of orient everyone with some maps. So with Longview, we looked at two turning basin configurations. The first is this small blue box. And just for everyone's awareness, everything that is highlighted in red is an existing federal feature. And so the long thin strip with the dotted line going through the middle, that's the existing Columbia River Federal Navigation Channel. That's maintained at 43 feet. The dotted line is the center line. And then the existing Longview turning basin, which is the remainder of the red moving towards the Port of Longview, is a federal turning basin that is maintained at 40 feet, so 3 feet shallower than the existing federal navigation channel. The blue box indicates the area that we would look to deepen to 43 feet. It includes the areas in front of berths 6 through 9, which are the primary berths that support the bulk commodities that require some of these bigger, deeper drafting vessels at Longview. So in addition to the existing turning basin footprint, on the Washington side, on the north, in front of berth 9, we would expand into an area that is currently maintained by the Port of Longview to 43 feet. That services the EGT facility, the export grain terminal. And we would also expand the turning basin onto the Oregon side, beyond the Federal Navigation Channel, in order to meet our width requirements for turning. So the dimensions associated with this are 3,600 feet in length with 1,250 feet in width. And we looked at it at a number of depths. So starting at 40 feet, which is kind of existing conditions, up to 45 feet. And what you're seeing in the table on the left are the quantities of material that would need to be removed in order to achieve that depth. And so what we're really looking at here is just sand. We didn't find any rock within the footprint of this, and CY stands for cubic yards. So we're looking at anywhere between 1,000 and 45,000 cubic yards, depending on the depth of the turning basin. Next slide. We also looked at the full footprint of the Longview turning basin. And so it's that original box that was shown, but extending all the way down to berth 1. The Port of Longview continues to expand. They're revitalizing some existing berths and terminals. And so in order to meet potential future needs, we also considered this larger footprint. It also gives us the ability to turn 2 vessels at the same time. And when you look in comparison to the previous slide, the volumes, the dredge quantities do not increase significantly. So as we move into the existing turning basin, a lot of that just kind of naturally exists deeper than the 40 feet that we're authorized to dredge to. And so what we see is very limited additional dredging required to expand that turning basin across the full footprint. Next slide. So the next alternative is consideration of a new turning basin, a new federal turning basin at Lower Martin Bar. As before, the red area is the existing Federal Navigation Channel with the dotted line is the center line. The blue box is the area that's being considered for the establishment of a new federal turning basin. This is in an area that mostly overlaps with a local service facility, an access maintenance area that the Port of Kalama dredges and uses to service the Temco grain facility. We would look at taking that over at the end of a dredge season, which is why you see no quantities in order to establish that new federal turning basin. We would take it over at a depth of 43 feet or greater, and so from an implementation standpoint, there would be no additional cost or volume. Next slide. So alternative 3 is looking at those combined turning basins. I'll just say that we selected the larger footprint based off of an economic comparison between the two of them. The way that we consider these is net economic development benefits. And so we look at our annual costs versus our annual benefits, and we seek to maximize the net benefits associated with our project. So we looked at those two footprints. We made the determination that alternative 1B, the larger footprint for Longview, was the benefits maximizing of the two. And so that's what we carried forward into the rest of our alternatives for comparison. You can see that the sand quantities are the same as alternative 1B because it would just be additional dredging required at the Port of Longview turning basin to deepen that. Next slide. So finally, we looked at alternative 5. This is the combined turning basins that we showed on the slide before. We also did an analysis to determine the most suitable locations to place stern anchor buoys. We considered a range of locations, and After our analysis, we determined that there were three that were economically justified. The first one on the left-hand side map, that's just downstream from the Longview turning basin. You'll see that there's two boxes there. On the right-hand side is the anchorage and the placement of the stern anchor buoy. The narrower band is a realignment of the channel that we are considering in order to make transit under the bridge safer and to avoid kind of that turn. So ships will be able to more easily transit under the high point of the bridge and hopefully improve safety there. We also identified two other locations for placement of stern anchor buoys on the right side of the map across from Cottonwood Island and then further upstream near the port of Kalama. You can see the Lower Martin Bar, the proposed Lower Martin Bar turning basin a little bit further upstream from that. Next slide. So after analysis, our recommended plan is alternative 5 at a depth of 43 feet. So it makes sense that the turning basins maximize benefits at a depth similar to the Federal Navigation Channel that would allow both the ports of Longview and Kalama to load vessels to fully maximize utilization of that channel. Similarly, the stern anchor buoys were assessed at a depth of 43 feet in order to ensure that fully laden vessels could be anchored there. Next slide. So when the Corps of Engineers analyzes a project, we look at our existing project or our existing conditions, and we look at what would change if we did a project. So under existing condition, the Corps of Engineers takes no action, right? Things remain the same, and what would we expect to see? We would likely see increased congestion and traffic delays in the lower Columbia River. There is a finite amount of capacity, and the longer that those vessels stay idling at the berths is a decrease in terms of the number of vessels and the total throughput of those facilities. We would see a continuation or a decrease in accessibility for deep draft vessels, and so vessels that need to load to 43 feet may not be able to go to ports of Kalama or Longview if the water depth is not there. We would potentially see a decrease in imports and exports at both the port of Longview and the port of Kalama because of this. And then the having fewer turning basins within the system for deep draft vessels means that vessels are going to have to transit further upstream or downstream to turn in an emergency case or just to transit out of the system. The benefits associated with the width project condition, it's an overall decrease in congestion and traffic delays within the system as a whole. Increased accessibility for these vessels that require the full 43-foot draft, the potential for increased imports and exports at the Port of Longview and the Port of Kalama. We have vessels that are queuing for shorter periods of time. We have vessels that need to wait on the berth for a shorter period of time, allowing loading of more vessels in a year. More available turning basins for deep drafting vessels will result in a decrease in greenhouse gas emissions. So because these vessels don't hook up to shore power, they continue to idle as they wait at the berth. And so moving them in and out of the system will produce a net decrease in greenhouse gas emissions. And so we are proposing the placement of our dredge material at a beach nourishment site with the objective of creating habitat that would benefit juvenile salmonids, and then all of the associated socioeconomic benefits with increased jobs during construction and increased activities at the port. Next slide. So there are some environmental consequences that have been identified as part of the recommended plan. It is important to state that we did not identify any significant impacts that would have long-term negative consequences to the Columbia River. The majority of impacts that are identified and are outlined in the environmental assessment are short-term during construction or minor long-term to moderate adverse impacts. associated with changes to the hydraulics of the river system. And so although we've identified some adverse impacts, the Corps of Engineers is going to implement best management practices that are recommended by the resource agencies in order to further reduce those impacts. And so we would also see both short and long-term beneficial impacts from an environmental perspective in addition to the economic side. Section 5 of the report is the majority of the environmental assessment, and so on a resource-by-resource basis, that is outlined in the draft report that's posted online. Next slide. This is a table of some of the environmental laws that our recommended action is working for compliance with. And so the Clean Air Act, the Clean Water Act, NEPA, National Environmental Policy Act, Endangered Species Act, Marine Mammal Protection Act, National Historic Preservation, and Environmental Justice. So those are kind of some key overarching environmental laws that we are required to meet and that we are working through with the resource agencies and others to ensure that any project that we recommend is compliant. Next slide. So the study timeline and opportunities for public involvement. Right now, July of this year, the draft feasibility report has been released for public review. As I mentioned earlier, that's a 30-day period. We're about halfway through it. That period closes on August 3. And so there are multiple ways to provide comments over the next 2 weeks, and we encourage anyone who has any concerns or support or feedback on the project to provide that to us. By summer of 2025, so about a year from now, we'll be looking to finalize this feasibility report and environmental assessment, and we'll be working through our administrative process to complete the chief's report. Once the report is finalized, we will again post it online so everyone will have access to it as a public document. And then at the earliest, in 2026, we would initiate design and construction. So once we complete this report, Congress needs to authorize us to move into a design and construction of this project, and then they need to appropriate funds for us to implement. And so if we were to move on a seamless timeline, we would be looking at 2026 as the time that we would start design. Next slide. So I think I can turn it back over to Karina. She covered this before, but just ways to provide comments.
Thank you, Elliot. Yes, so as Elliot said, these are the 3 avenues for you to provide a comment, a formal comment, but we can open it up for questions now. So please provide your question if you have one in the chat. I'm not seeing one so far. It does look like, Albert, you have your hand raised. So I will allow you to talk. Oh, never mind. You lowered your hand. So I'm still not seeing any chats come in. If you did provide a chat and for some reason I'm not seeing it, maybe raise your hand so I can call on you. Oh, looks like Dina, you have your hand raised. So I'm going to go ahead and unmute you.
Can you hear me?
Yes.
Okay. I'm trying to put something in the chat and it's saying that the chat is disabled.
Oh, okay. Thank you.
Just FYI.
Thank you so much.
Yeah, no worries.
Oh,
Actually, I was just going to ask if you could speak a little bit more to the during construction, you mentioned there could be some changes to the hydrology that could lead to short-term environmental impacts or potentially moderate impacts. Could you speak a little bit more to what that means exactly?
Yeah, so I can start that answer. So like we did say, all those details are provided in the full IFR EA online. So if you'd like the full spiel, please look at that. But a quick overview is that river hydraulics will be temporarily impacted during construction. Long-term impacts would occur during the permanent installation of the stern anchor buoys. These impacts are very minor though, because it's really just changing, it's just a minor change in the riverbed. And then as far as hydrology, there would be minor impacts during construction to the water quality during dredging activities. I don't know if Elliot or David or Laura want to add to that, but that's kind of a quick overview of water quality, hydrology, and river hydraulics. Okay, thank you, Dina. And everyone should be able to chat now. I'm sorry, it looks like I did have that function off. So now you can chat.